Hey, welcome to another episode of SMARTDrive. In this episode, we will discuss about the differences between alloy wheels and the steel wheels. Alloy wheels are made up of different materials. It is a mixture of metals, mainly contains aluminum and magnesium, therefore also called as mag wheels. The main difference between alloy wheels and the steel wheels comes with the cost. As you can see, when you are switching to more advanced variants of a car, it will give you alloy wheel version. Strength is the another advantage which goes to the alloy wheel. It has a great strength and give you maximum stability. Service life of alloy wheel is very great as compared to steel wheel. Rusting is compulsory with the steel wheels. On the other hand, alloy wheels are not possible to get rusted. When you are talking about design, alloy wheels are very much balanced and lean. On the other hand, steel wheels are welded and heavy. In case of braking, alloy wheels are more effective as compared to steel. In case of heat conductivity, alloy wheels are very much effective and more conductive to heat than compared to steel. In case of repairing, steel wheels get repaired easily. Now let's have a look how the steel wheels are made.
The driver will get the trophy and the credit, but a good set of wheels is behind every win. They start with high-strength, low-alloy steel, which is a very stable material. The first of a series of die presses gives the center disc a concave profile and forms lug holes. The next press punches a hole for the hub and others called windows. Windows help cool the brakes while maintaining strength where needed. They stamp rings around the windows. This is called coining. The rings give the windows a nicer look, and the action compresses the steel to further strengthen the part. The next press is critical. It forces the disc into a bowl shape and gives it precise dimensions to accommodate brakes. The specific angles also reinforce the part. It has taken a lot of punching and pressing, but the center disc of this racing wheel has really taken shape. A smaller press now punches out the lug holes that were outlined earlier. These holes will allow the wheel to be mounted to a vehicle. Then the center disc goes for a spin as a series of tools trim it. The part is now complete. To make the rim, a machine unwinds coiled steel and rollers iron out the curl. A mechanical arm maintains slack as the flattened steel goes under the knife. The blade, called a shearer, cuts the steel to length and stamps product information onto it in one swoop. An operator now winds the steel between three rollers to twist it into a band. He then places the band into the jaws of a welder, which fuses the two ends together. He then slides the band into a machine that scrapes off excess material from the weld. It's still warm, so it can be easily removed. Now, the band comes under some serious pressure as a machine forces it around dies at both ends to create flares. This rack transfers the rim to a series of rollers, which shape its inner ledge. This part of the rim is called the bead seat, and it will be attached to the bead wall of the tire. They trim the rim to make the edges neater. This finishes off the part. They nestle the center disc loosely in the rim. As the rim spins, they heat the outside with a torch. This causes the steel to expand, and the center disc drops further into the rim. As the rim cools, it contracts, shrinking to the center part. The two parts are now interconnected, and a welding job makes the bond permanent. A worker drills threaded holes onto the wheel to attach valve stems. As it exits, the drill turns in reverse so it doesn't wreck the threads. After a fresh coat of paint, they apply a thread locking adhesive to the valve stems and screw them into the holes. The valves will be used to add air to the tires. The wheel rotates as a small roller paints a stripe onto the rim for accent. Then a press stamps a number onto it to identify this wheel in the event of a problem. And now this wheel is on a fast track to the finish line.
Now let's have a look how alloy wheels are made.
Rather than basic steel wheels covered with a hubcap. Called mag wheels because when they first came out, they were made of an alloy of magnesium. Today's alloy wheels are made of an aluminum alloy, which is far more durable. Aluminum alloy wheels are not only more attractive than standard steel wheels, they're also a fraction of the weight, and therefore require less energy to rotate. This contributes to greater fuel efficiency, as well as better handling, acceleration, and braking. Manufacturing them begins with high-grade aluminum alloy, containing 97% aluminum. A furnace heats the ingots to 750 degrees Celsius. They liquefy in about 25 minutes. The molten aluminum then flows directly to a mixer, in which they inject argon gas, which enables them to remove the hydrogen. This increases the density, making the aluminum less porous when solidified. After adding powdered titanium, magnesium, and other metallic elements to further strengthen the aluminum, they blend in flux, a chemical which draws aluminum oxide to the surface. They skim off this impurity along with the flux, and the liquid aluminum is ready for casting. The wheel mold is made of high-strength steel. It's actually a set of 3 molds: the upper mold, which forms the inside face of the wheel, the 4-part side mold, which forms the wheel's edge, and the lower mold, which forms the outer face. That's the side with the design, so this is the most intricate mold. It takes 3 to 4 weeks to produce a mold. Computer simulations check the flow and temperature of the liquid aluminum, factors critical for preventing casting defects. The casting machine is designed to fill the mold from the bottom by pressurized injection. Injecting upward through the bottom, rather than pouring downward into the top, reduces the risk of air bubbles, which cause defects. Right before casting, the molten metal flows through a filter sheet made of high-temperature resistant ceramic. This traps additional aluminum oxide. Once cast, the aluminum takes about 7 to 10 minutes to solidify. Then the mold automatically opens, releasing the newly cast wheel. Workers submerge it in lukewarm water for a few minutes. This cools it down enough to be handled. The wheel undergoes a complex heat treatment process that takes 12 hours from start to finish. First, they heat the wheel to 500 degrees Celsius. This rearranges the molecular structure, strengthening the metal. Next, what's known as quenching. They submerge the wheel in 80-degree water for 30 seconds. This locks in that new strength. Then they reheat the wheel, this time to 180 degrees for 9 hours, to further stabilize the metal. The wheel doesn't come out of the mold in perfect condition. The edges are rough due to some excess metal that has to be trimmed off. So they mount the wheel on a computer-guided lathe. It precision machines the sides, refining them to within 0.05 millimeters of the measurements specified in the technical drawings. As for the more intricate face of the wheel, a worker manually trims the edges with a blade. The shape now finalized, it's time to test the wheel to make sure it's airtight. While pumping air into the wheel, they submerge it in water. Should any air bubbles appear, it would mean there's a pinhole in the metal or some shrinkage, in which case the wheel would fail inspection. No air bubbles? The wheel proceeds to the automated painting line. First, a base coat, then a coat of color, which can be anything from classic silver or black to a flashier shade. Then a clear coat to protect the paint and prevent corrosion. From every 1,500 or so wheels, the factory randomly selects 2 or 3 to test for performance and wear. Workers install the decorative cap that covers the center hub. It typically bears the specific brand's logo. Then, a final cosmetic inspection to make sure these aluminum alloy wheels look as good as they perform.
Now let's discuss the parameter to be considered buying new set of wheels. If your car will be driven above 100 km per hour, please buy alloy wheels. It will give you better control. The cars having disc brake must go with the alloy wheels. Alloy wheels are light in weight and have a great stability. Another most important factor to maintain the tire pressures. The best suitable for tubeless tires are alloy wheels, and for tube type tires is a steel wheel. Smart tips. Avoid repainting your steel wheels. Rusted steel wheels must be replaced with new ones.